So yes, so my name is Mary Grygleski, and thank you for the introduction. And I've been with IBM, just a quick thing is I've been for 2 years, and I'm also the Chicago Java Users Group president this year. So yeah, and okay, let me kind of make sure I can connect. Okay, so I'll just kind of give a quick introduction, and because it's a short session, but also too, I'm assuming maybe not everybody has had some background of reactive Java as it kind of pertains to reactive Java. So I'm going to be touching on some of the basic things. So pardon me if it's kind of too easy for you if you're already familiar with it. So so as such, let me kind of quickly start. Why Virtex? Virtex is an open source project. That's basically it's a Eclipse Foundation project. It's very lightweight, and also too is a library that's reactive, supports reactive computing, and also event-driven programming. And I actually became more interested in it also because of Quarkus. If some of you are familiar in the Java ecosystem, Quarkus is a newer framework that's cloud native ready, and it's developed by Red Hat. And underneath the hood too, Quarkus supports also reactive style of computing. And it's actually pretty interesting that it supports both imperative as well as declarative style of programming. So in other words, like synchronous and non-synchronous, blocking, non-blocking kind of processing in the system. And it's all because of the capability through Virtex. And also now with a new library called Mutiny too, that's actually also supports a lot of reactive streams implementation too. And that's what Quarkus is making use of. And I'm also myself am finding Virtex to be very lightweight, somewhat like easier to use to begin with than maybe some of the other frameworks, for example. So I'm finding it to be quite interesting. So that's why I've kind of picked this as my topic for a reactive. And it's very flexible, and also very polyglot in nature, meaning that it doesn't dictate what language you should be using. And in fact, I believe you can do Go, and I haven't tried it, but you can have Go, you can have JavaScript, Ruby, Python, you name it. So you can also have that. So I'll have some code to demonstrate how you can do it. And essentially you are having your Virtex runtime. And now I'm not talking about cloud at this point. You can spin up your Virtex control center, and you can basically deploy vertical that are written in other languages. So in other words, it's very interoperable. And to me, I find it to be very interesting with a reactive way of doing things is because of the messaging nature, and you can have very loosely coupled systems that you can essentially build up different pipelines, and the opportunities are limitless. And especially I think in today's world too, when we're trying to also upgrade any kind of legacy situation, I feel it's an opportunity to be kind of uncovered of new ways of doing things, and we deploy kind of systems that are more asynchronous in nature. You can actually connect different things, and the messaging can kind of flow through many different types of systems. So. Okay, so now then let me move a bit now and then talking about Quarkus a little bit. This one, I borrowed this slide from Quarkus. So Quarkus and Virtex, how are they related? So from the documentation here, you can see from the application, you're coding, and then it goes through the routing layer. And basically in Quarkus is the Virtex that handles all of the request and response. Virtex has this very efficient like event bus that handles all of the events that comes in and allows for asynchronous style of programming. So just a bit too, now that I've given a bit of taste of the Virtex, so I'll kind of give a bit of introduction to reactive Java in case some of you may not be as familiar. And first of all, when we talk about reactive systems, we cannot avoid not talking about the reactive manifesto. This one is guidelines that basically provide guidance on what a reactive system should be. And it needs to fulfill like four tenets of this. So first and foremost is the responsive aspect of it, meaning that requests coming into a system, it needs to be handled in a very timely manner, so very responsive. And also too, if there are any spike in load, then the system also needs to be very elastic. It should be able to respond to requests accordingly and spin up more processes to handle them. So very elastic, very scalable, so that your system's performance should not suffer. And then if you look into also the resiliency part, the resilience meaning that if there are any error condition, then likewise too, the system needs to be very responsive, being able to respond to error and handle them accordingly, and be able to recover from it in a very timely manner. So those are kind of in a nutshell what those are. And all of these three are actually enabled by a system that needs to be very much like enabled by their message-driven nature. And in a message-driven systems too, is that messages are being exchanged between like two kind of like known addresses, and they go from like, receiver or actually sender, and sender going to receiver. It has kind of a known address. Now, the thing is too, there's also the event-driven aspect. Event-driven and message-driven is kind of not exactly the same, because events are essentially, they are messages that get emitted, and there are no kind of address that's associated with the messages. I guess like unless you really specify something, but then it wouldn't be like considered like all event-driven in that case. So it's a truly event-driven is sort of like publish, subscribe type of scenario. And so pops up, then you basically is the consumers who are interested in the messages will have to subscribe to it. So that's more of an event-driven. But in this case, like reactive, it is event-driven in nature, but the system itself needs to kind of provide this message-driven capability. Okay, so now let me also then point out too, in the Java world too, and as such today I'm talking about reactive is mostly like pertain to the, on the implementation side is on Java. But the thing is too, with the concepts, it's applicable to any kind of systems. So now I like to point out, these are like the more popular Java frameworks or toolkits or libraries that support like reactive processing. And these are not the only ones, but I like to highlight them because they are the ones that are more popular at this point. So yes, then now I'll be talking about Vertex, and there are also RxJava, which is came out of reactive extension, and that's actually started by Microsoft in, I think, the early like 2010 timeframe. In fact, it was Rx.net who came out first, and then Netflix discovered or found that out, and so they ported it to Java. So that will be RxJava, and then all of the other language libraries, frameworks, they kind of follow suit. There's also RxJS and Rx Python. Now there's also Kotlin, and as such, RxJava was very popular with Android mobile apps in the beginning, especially. RxJava 1 doesn't have support for backpressure, but RxJava 2 has. And now RxJava 2, the implementation, all of that's being engineered by essentially the same group of folks who are working on the Project Reactor. So from the Spring Project Reactor side, so the engineering teams, they're the same. So you find that their RxJava is very flexible in terms of support for the operators, the observables. So RxJava 2 support backpressure, but RxJava 1 doesn't. So, and here too, I bring to your attention Project Reactor as from VMware, or what used to be Pivotal. So that's the Spring folks. And so that's that. And also there's also a Spring Webflux, which is their web framework that supports reactive and utilizing the Project Reactor. And then there's also MicroProfile, which actually came out of more of the enterprise Java side, and it's an Eclipse Foundation project. And it's kind of has a more focus too on supporting like microservices, so reactive style of messaging for enterprise Java purpose. So just a word to IBM, we're quite heavily involved with this too. And then there's also Akka and the Play framework and Lagom. And Akka, as such, came from Lightband, and the company that led the design of the Reactive Manifesto by Dr. Martin Odersky. So Akka, and then there's also Lagom, which is an opinionated framework for building microservices that's built on top of Akka. And Play is also like depending on or kind of built on top of Akka, but that's for more the front end type of implementation. So, okay, so that's some introduction of this. And also another interesting library that comes out, has come out quite recently. In fact, the 1.0 version just came out like a couple months ago this year, is RSocket, the reactive socket. And that's being initiated by these companies here that they initiated this effort. And now, of course, pivotal is VMware. This slide, in fact, I got it from SpringOne, the SpringOne platform too. So it's kind of described here to Reactive Socket is an open source layer 5 and 6 communication protocol that's based on the reactive streams. So talking about which two, there's also this reactive streams, which is the specification that guides how to like manage like asynchronous processing for non-blocking streams and also essentially the back pressure mechanisms too. So it kind of defines the standard for it, and our socket supports that as well. So, and also our socket too, it's actually quite flexible in terms of it supports all kinds of languages and platforms and different types of use cases like mobile, edge, and IoT. So, all right, and I'll look at the time. I probably have about 20 minutes. So, okay, now let me kind of get more into Vertex. And Vertex too has some good examples of use cases. So these are kind of a list of things. I won't read them all out. You can also find out too, but I want to point out too, the event bus is what kind of makes Vertex to be a pretty capable, powerful library to the event bus. So, and then there are, different use cases could be doing like periodic delayed actions, this type of thing, and kind of clustering all these things. And so some getting a bit into more the code level on Java. So this is how you can include them in your Maven and your POM file. This is currently the version is on 3.9.2 and the 4.0 is being worked on. I guess have more support for more the futures and promises that towards that direction too. So, and then there's also the Gradle specific dependencies, how you would do it. If you want to include your Vertex for the core library. And then there are other libraries too that you can use with the core Vertex library to do different things. For example, like the web also has a different library for doing the web stuff. It has very good integration with RxJava as well. Because RxJava is really good with its set of very powerful like operators to operate on the streams. So Vertex kind of essentially works with its kind of side-by-side and making it quite powerful. So then you can leverage on the Vertex event bus to handle your asynchronous processing. So, okay, so here with Vertex too, it's simple in the sense that if you run it, let's say, without the cloud I'm still talking about without the cloud, there's actually just a control center. So you just need to essentially do a vertex.vertex and it will bring up your control center. And then in order to add in some options into your runtime, and you can just basically pass it in your options and then basically set worker pool size. And they're also like setting the cluster, for example, other kind of configuration parameters. And Vertex as such is very event-driven in nature. So these are some of the example events, like a timer has fired, some data has arrived on a socket, or if it has been read from a disk, an exception has occurred on an HTTP server has received a request. And some event handling part, these are example in the code format in Java, is that if you receive a timer event every second, you can basically make use of the call called set periodic, and you pass in, here is 1,000 milliseconds, meaning like 1 second, you want to print out a line that says timer fired. Over here, you can also receive an HTTP request, and every time you do want to implement a handler to handle it. So this is a Lambda that basically takes in the request and then essentially say .response.end that will print out the word hello world in this case. Okay, and then some word too on how Vertex is. It has this vertical model that it uses. It's similar to the actor model in Akka, but it's not a requirement. But the thing is too, is actually recommended to use to implement your vertical, or basically to extend your abstract vertical. It's a unit of deployment in Vertex, and it processes incoming events over the event loop. So these are like some of the events which I also talked about earlier, like timing events, messages sent by other verticals. And the event loop, they are typically used in asynchronous programming models, and each event will get processed in a reasonable amount of time so that it's not blocking the event loop. And every event loop is attached to a thread too. And by default, Vertex attaches like two event loops per CPU core thread. So just also a word too on threading too. It's interesting because I also been asked by other audience too at my other presentation. They were saying that, well, why do you want to bother using reactive? And also now too with Java, there's also a project called Project Loom that's actually being worked on. It's essentially virtual threads. It's like the next generation of threading. Now, getting back, for reactive, the thing is too is that what used to be before reactive is that there's threading, but the thread was being done in the kernel, basically the main, all of the IO is using your main kernel thread. So as you can imagine, if anything, it needs to be done, then you have to do a lot of context switching with your threads. But now with reactive, it's basically move all of these threads into the user space. So in that case, you don't tie up your main thread in your kernel. So that's kind of the idea. Okay, so now going back. So a regular vertical, then will always process threads, events on the same thread. So then there's no need to, for like application developers, if you're using this library, then there's no need to worry about use any kind of threading coordination mechanism to manipulate a state, for example. And some example is that a vertical can be passed some configuration like credentials and network addresses, all of these things. And the nice thing too about verticals is that if you kind of extend your abstract or vertical, it can actually be deployed like several times too. So this is just a diagram that I kind of borrow from the documentation. Is if you have configuration coming in, it's handled by the vertical itself can actually be deployed like multiple times too in here. So as you can see, so this kind of explain how it is being done. Okay, and then another aspect of Vertex is its very highly polyglot nature of it. So it supports like multiple languages, all of these listed here. And it doesn't force the usage of any languages, but allows programmers to pick and choose or any or all. And it's really true interoperability too. It's made possible by the event bus and the messaging infrastructure. So here is an example illustration too, which I will bring you next in the next set of talk or next minute or so to show you the code of a Vertex polyglot implementation. So over there too, I'm just doing something very simple for demo purpose is basically a main API vertical. I call it a gateway that will funnel all of the HTTP requests. And then all of these requests coming in, then you see that is the Vertex event bus that handles kind of the routing and all of those things for this main vertical. And then each requests are being handled differently by different vertical that implements they're all each worker vertical is being implemented in a different language. So one is Java and the other Kotlin and then JavaScript. And for JavaScript too, in order to be kind of connecting to the main vertical is basically I'm using a sock.js bridge to do it too. So, and then with that, let me then, so now I'll go into here. I'll just quickly bring up my code here. Okay, and excuse me, and I just had to reboot my machine, so I kind of maybe a little slow in bringing stuff up, and it took a bit longer time. So, okay, so here we go. Oh, this was my workshop from yesterday. I'm sorry, and over here, yeah, this is it. So, okay, so I'll just kind of make this thing. Okay, I think you can see it. Okay, okay. So let me kind of first, assuming not everybody has had some. Seen a Vertex situation. So I'll just quickly show you a hello vertical and it's a basic like hello world. There's any kind of system too when we first want to show something is always hello world. So this one I call it hello vertical. So how would you do it in Vertex? You want to extend the abstract vertical. And in here too, you can see the thing is with this is that you extend it and you basically can override a start method. The start method is where you can then set up all of your things that you need to do. And in this case too, I'm setting a timer in here, set periodic, and every 5 seconds, I will print out the word, send it to my logger tick. And then the other example here is to create an HTTP server. So basically over here too, I create my server. Then I also specify my request handler. And then over here too, all it's doing is basically print out a hello. And essentially I bind this listener to listen on port 8080 in this case. And then in order to start this program in Java, then in my main, all I need to do is to start up my control center. And all I need to do here then will be just doing a deploy vertical. So if you deploy it, I basically say, I just want to instantiate my vertical. In here too is my hello vertical. So if I kind of highlight in here, it shows that it deploys a vertical instance that you have created for yourself. So, okay, so this is just the basic one. So now I'll move into the code for the polyglot side. So this one too, if you recall my diagram in there, then this is like the main API gateway vertical. So over here, as you can see, I wanted to also quickly show you, just without too much like specific, but I still need to be showing you, like I'm using the Vertex RxJava library to do some of these work, because then Vertex then can make use of RxJava's operators in here. So basically to my main vertical, I'll extend the abstract vertical. And then in my start here, I want to also point out is that I'm also reading from a file that contains configuration information. So this is the config.json. So just to give you an idea, this is just a JSON file that lists out the different, thing in here. I'm sorry, it looks like the, my thing may be blocking, so I'm sorry about that. So, okay. And okay, so over here too, just want to show you too in the configuration, then what we're doing in here, we read in the configuration, and basically the thing is over here is of interest is that you can make use of their config retriever and set the listener to it. So then if anytime you're making changes during the runtime, I basically have a listener that listens for any changes and then read all of the configuration changes into memory without having had to bring down your server. So this is one part. And then another thing is that in my code here, I just wanted to show you. So once I start up my this API gateway, then I basically will set up the router to kind of link up with the Vertex control center with my router. And then I will set up some of these CORS handler as well as like setting up my call, like the request mapping. So I will map to, like, if it's kind of asking for health, then I will call this generate health method and so on and so forth. And as such too, I have some to do because I'm doing also a weekly Twitch. I'm trying to also work on this. So it's just some work in progress I'm trying to show you. And then over here too, in order to make it useful, then I will have to create my HTTP server listener. And over here too, then this is the part that I will call to actually deploy these different worker verticals. So now in my different worker verticals, I'm also implementing them in different language. So deploy Java worker. So we'll take a look into this here. Okay, so this is the part how I would just deploy it. If you recall in the hello world, then all I do is vertex .deploy vertical. And then in this case, then I will then invoke or give the name of the class, which is the Java class file in here. And that's all I would need to do is basically invoke it using the deploy vertical in here. And then likewise too, if I want to deploy my Kotlin worker, then I do a deploy vertical and basically call it Kotlin worker vertical doing a .class .get name. And then for JavaScript is deploy vertical, and then I pass in the JavaScript that's needed. So over here, let me kind of just quickly take a look. And this worker vertical at the moment is not doing anything, too like useful for production purpose, but just for illustration purpose, right? So in order to implement your worker vertical, you do it the same way as you do for like a regular any kind of vertical. So it's kind of becoming quite powerful in the sense that you can write one vertical and use that as your primary vertical, that you can actually use it for deploying other verticals, and they can be deployed multiple times. So yeah, so that's kind of an example of how you can leverage on this polyglot nature of Vertex. Okay, so with that, let me kind of switch back to my slide in here, and I will then get into, because of the time, I will need to kind of hurry a little bit. We'll talk about the part on actually deploying. So it's dealing with more of a building and deployment to the cloud now. So all of this I've been talking about just like Vertex, and you just how do you build and write it and deploy it and kind of run it, run the Vertex in the JVM by itself. So nothing to do with cloud. But now let's bring it to the cloud part. So this part as such too, the example I'm giving is just the basic hello world and how do we deploy it to the cloud. So first of all too, and even though this isn't like a workshop scenario, but I have this in here, is that to invite you, if you like, to kind of get a taste of the IBM cloud, and we have a free tier access. So QR code, but I can give that to you later too, but just wanted to quickly show you if you can do that. And so now then I will talk about the serverless deployment part. So as such too, for serverless, we're talking about cloud native computing. We want to build and deploy, run and operate scalable applications in modern dynamic environments. And I just wanted to bring up too, I feel like when I first study about reactive is by itself, you're just Java, you're running it in JVM. But the fact is the nature of reactive application, I think they kind of being set up to be easily deployed as a cloud native applications, because in any kind of container situation, Kubernetes, for example, you can make use of the clustering capability. Now in Vertex too, Vertex also has its own clustering too. And that's something I will be working on, hopefully like in a future talk, which I will be, is to see how we can actually use the Vertex clustering and also deploy it to Kubernetes, and how do we use it in Kubernetes clustering. But that will be left for a future talk. But for now, I just want to bring it up. Serverless deployment, the advantage is that it helps with your applications you're able to scale it up quite easily. And it's of course too, when we talk about serverless, it's not that there are no server, but it's, I think the server concern is being moved to your infrastructure rather than on your application level. So your applications can still function the way it is, but you leverage on the scalability or scalable capability in your infrastructure environment. So now cloud environments can be public, private, and hybrid. So just wanted to point that out. And over here too, some of the serverless deployment like application techniques would be containers, microservices, and serverless functions, and immutable infrastructure and declarative types of deployment. Okay, so, and this is just a quick note too. So when, and I will go into quickly doing the demo, is that in this case too, I'm using also like Docker to do my Docker build. And basically, it's actually simpler than you think. So you can do a Docker build, and basically, you say this is the line to use, essentially just Docker. And of course too, in that case, if you're using Docker, then you will need a Docker Hub account, so then you can build to it, and also then doing a push, then you push the image to the registry, after which then all you will need to do, well, of course, what I'm doing here sounds like magic, but there's also work too in terms of you setting up your cloud and setting up your OpenShift and setting up your Kubernetes cluster. And so with that, let me then switch back to some of my code in here. Let me bring it up. And I do have to say that because I had to reboot my machine. So I'm just going to use the example that I had from my workshop yesterday. I was doing it at JFall in Amsterdam. So over here too, I'm also like using an Hello World abstract. I'm extending my abstract vertical. This is my Vertex app. So also kind of doing some simple things, and all it does is just I'm setting up an HTTP server. So how I would do it, let me then do it. Okay, rather than do it in an IDE, I'm just going to do it over in my, in a shell in here. I'll use a terminal. So you know what I would do? I'm sorry. Like I said, I kind of have to set up a couple of things too. First, but okay. Over here too, I just need to set up the this one here. I'm sorry. Let me. I guess I still have some time, right, Francesco? I just want to make sure. Okay.
Straight. We've got 4 minutes. Don't worry.
4 minutes. Okay. All right. Let me kind of quickly. Okay. And then I just want to show this part, or at least being able to. And I basically wanted to set this up so then I can just do a quick Maven build. Again, not sure if folks are familiar with Maven because, and I'm not familiar with how Erlang does it, but for Java, we usually use Maven or Gradle. These are like the usual thing. So over here, I already have done some work, but the thing is, in order to do that, I just need to do a Maven package. So of course, all of these things are set up. So I use my POM file, which describes how to build it. So over here to, some of the things has already been done, but while that is building, I just wanted to quickly, okay. So over here too, it basically has quickly built. And yesterday I was running the JFall workshop. So it basically sends it to this jar file. So over here, so in this case, then let me then also bring up this guy in here. And so, okay, so just treat it like magic. So target, so see this thing, right? This jar file is what kind of get produced in here. But the thing is, then I have my Docker file that describe how I actually am going to deploy doing the Docker build. Just now in the slide too, I'm basically doing a Docker build, which I have already done it. So I build it and it generates that image. Then from there, then it will copy that jar file, which I just produced in here, over getting to my deployments directory. Then all I need to do is doing a Docker push. Then it will get to my Docker hub. And then in this case, so everything's all set. Then basically you can then go to your, you can do it on your command line. If you do your command line, any kind of cloud environment, you do want to like do a logon. Say if it's like OpenShift and you can do a logon, and there's also certain parameters that you have set up. But as I mentioned, I'm also having the, let me quickly bring up my cloud to just show it to you too. So this is my, my cluster in here. And okay, I just will be slightly quickly. Okay, so this is my, essentially my Kubernetes cluster. And then, and one of the things that is nice too with this interface in IBM Cloud, I can basically bring up a cloud shell. So the shell that interacts with my cloud. And I probably won't have this set up in here right now, and I only have 1 minute left. But I do want to quickly show you is that the way you can do it is that once you have your image like pushed to your Docker hub, then all you need to do, I was showing the command, what you would need to do. It kind of sometimes takes a long time to do it. All you need to do, we have what we call a service YAML file. Okay, looks like it is up now, but let me just quickly show you. So this too is that what I'm making use of is the Knative, and Knative, in a long story short, is basically the tooling to work with Kubernetes, and it hides some of the complexity. One of the things it helps you to do is to do the deployment part. So the thing is, all we need to do in this case would be like you specify, your Knative. It has two components. The components we're using would be called Knative Serving that helps you with deployment. It manages also your revisions and some of your traffic management too on your Kubernetes container. So all of these things, once you specify it, and then over here is what I have pushed to my Docker hub. So in this case, my Docker, the URL, and then I basically, the conference happened to be JFall, that's how I name it. Then basically with this YAML file, then all you need to do is doing an OC apply. This won't work now because, and then file, actually it'd be like the file name, and then your service YAML, and that's all it's needed. So once you get pushed, then your components will then, in this case, your Vertex app will then be launched onto your OpenShift. So that's a quick demonstration. Okay, looks like my cloud shell is up. So the shell essentially enables you to connect to your cloud without you having had to do as much of all the setup that you would have to do otherwise. So, but yeah, but hopefully this kind of gives you a sense of how you can like quickly do this kind of deploying a reactive microservice. So yeah, and I understand, I think I'm time's up in terms of my lecture part. So thank you very much. And I hope it's not like too much of a big rush, but so I will.
Thank you so much, Mary. No, it was great. What we'll have to do is, I have a few questions myself, but what we'll do is we'll ask them through the Wova app, in the Q&A section, and you can then answer them there. And your talk will also very soon be available, for everyone else to see as well.
Okay.
It's getting late here in Europe, but and so they might be posting questions as well in the app.
Okay. Okay, that's
All
cool.
right.
Okay, then. Thank you.
Thank you so much.
Thank you for the opportunity. I hope it's been helpful, and please feel free to join my Discord. I just wanted to quickly kind of show you in here too. And also some of the documentation. I'll make the slides available, so then you can also have the link here. So, okay.
Perfect.
And thank you.